Hi guys, we meet again. So the video for part 3 for this week. Okay, so we continue our revision about free fall. Okay. In the absence of air resistance, all objects fall with the same acceleration regardless of their mass. Okay, so remember, okay, free fall. If free fall is the absence of air resistance. Okay, this acceleration is equal to gravitational field strength and is approximately 10 meter per second square near the Earth's surface. Okay, remember when we ignore the air resistance, when that one is the free fall, so acceleration A automatically becomes 10. Okay, so long as air resistance remains insignificant, the speed of a falling object will increase at a steady rate, getting larger the longer it falls for. Okay, so that's why free fall is related to the speed versus time graph, right? So look at here. So the speed is increasing steadily, or we call it increase at a steady rate. Okay, so the acceleration is the constant accelerate, right? Okay, look at this example. Okay, when a parachutist jumps out of an airplane, two main force act, which is weight and the air resistance. Okay, yeah, so this is the forces, the weight go down and then air resistance. So you know, you still remember, right? What is the function for the air resistance? To oppose the motions, right? Okay, look at this problem. Okay, okay, so the first, okay, this skydiver going down. Okay, so look at here. Initially the air resistance is very small. Okay, there is downward unbalanced force and the skydiver accelerate. Okay, here at first there is a downward unbalanced force, so the person accelerate lah. Okay, so as the skydiver speed up, okay, the air resistance increase. Okay, so when they go down with the increasing speed, okay, so the air resistance is opposed the motion, right? So of course the air resistance also increase. Okay, eventually the air resistance balance the weight, and so the skydiver travel at a constant speed, which that we call it terminal velocity. Okay, so when the air resistance balance with the weight, okay, so that's why after a while the force balance, the person travel at a constant terminal velocity. At here we call it constant terminal velocity. Okay, so next, when the parachute is open, the increase when the parachute is open, the increased air resistance on the parachute creates an upward unbalanced force, making the parachute slow down. Okay, so when the parachute is open, okay, still remember that the air resistance is related to the area, right? The surface area. So when the surface area of the parachute is increased, so the air resistance also increase. So that's why this skydiver go slow down. Okay, so when the parachute is open, there is a big upward unbalanced force, so the person slows down. Okay, so this graph shows how the parachute okay, this one go down like this. Okay, so this is still in the speed versus time graph. Okay, so but including the terminal velocity. Okay. This one at first just now, okay, when the skydiver go down, it's accelerate for the first part. Okay, after that the air resistance balance with the weight. Okay, so and then we have terminal velocity here. Why? Because have constant speed or constant terminal velocity. So when the constant terminal velocity is not accelerate lah. Okay, the acceleration is 0. Okay, so when the parachute is open, there is a large upward force which causes the person to decelerate. Here is decelerate, slow down, and here eventually the force balance once more and the person reach a new much slower. So this one is the terminal velocity. Okay, okay, let's do an example. Look at there about the free fall. Okay, number 1. A large stone initially at rest okay, at rest, fall from the top of building, the stone takes 3.2 seconds to fall to the ground. For this stone, air resistance can be ignored. Okay, so air resistance can be ignored. So of course, this one is the free fall, right? So please remind. Okay, please keep in your mind. If the air resistance can be ignored, so this is free fall. So how about the acceleration? A is equal to 10, right? Okay, number 1. Stating the formula that you use, show that the speed of the stone when it hits the ground is 32 meter per second. So this one is no calculation. It's just to show how you got the speed is 32. Okay, so how? Okay, sorry. Okay, we use the formula A equal to V minus U over T. Okay, and U is initially at rest just now, right? So U is 0. A, this one is the air resistance can be ignored. So this is free fall. So A is equal to 10. V, we want to find the V minus 0. T is 2 seconds. Okay, so this one bring to here. So V equal to 32 meter per second. Right? So like this. Easy, right? So you already shown the how to get the speed is 32 meter per second. So number 2, on figure 1.1, draw the speed time graph for the fall of the stone. Label with an X the line on the graph. Okay. Okay, the answer is like this. Okay, so the speed here 32. And then the time is 3.2 seconds. Okay, so this is the lines X. Okay, and then you can plot the graph lah. 3.2 and then 32. Okay, and then just make a straight line. Okay, number 3. Use the graph in 2 to determine the height of the building. Okay, so this one is the tricky question lah. So determine the height of the building. What is the mean by height of the building? Of course, they want to find the distance. Okay, the distance from the where the stone is fall down, right? So for speed versus time graph, the distance is the area under the graph. Okay, since this graph is the triangle, okay, so use the formula of triangle. 1 over 2 times 3.2 times 32. So you got the answer is 51 meter. Okay, next B. A smaller stone that then the stone in A fall from the same building. This stone is affected by air resistance. Now what include the air resistance? So what happened to the air resistance as the stone falls? Underline your choice. So what happened to the air resistance? Air resistance is increased. So when the air resistance is increased, okay, the answer here, air resistance is increased. When the air resistance is increased, what happened to the speed? It's slowing down, right? Okay, I think that's all for this week. Okay, thank you.